All right, questions 5 through 7 on the exam 3 review sheet ask us to add and subtract rational expressions or fractions. Now, the key to this, the thing that makes them trickier than the first 4 questions on the review sheet, is that you have to get a common denominator when you add and subtract fractions. So that's what we'll have to do first on each of these problems, is figure out what our common denominator is going to be. All right, so on the first one, in our denominators, you can see they're not common. We have 18x cubed y and we have 27x squared y cubed. So the first thing we need to find is a number that both 18 and 27 can divide into. So the easiest way I think to do that is to start listing the multiples of 18 and then list the multiples of 27 and then find a number that they have in common. So let's do multiples of 18. So if we're counting by 18, we start with 18 and then 18 times 2 is 36. 18 times 3 is 54. 18 times 4 is 72. 18 times 5 is 90, and we'll stop there. Maybe we'll find a common multiple when we start listing our factors of 27. Okay, so we'll start with 27. 27 times 2 is 54. And now you can see we already found a multiple that they have in common. Okay, so both numbers can be divided into 54. So that's going to serve as part of our common denominator. We'll rewrite these fractions with 54 at the bottom. Okay, so now let's look at the x's. I have an x cubed on my first fraction and an x squared. You're always going to use your largest exponent. So our common denominator will have x cubed. And if we look at the y's, we have a y in the first one and a y cubed in the second one. The largest exponent is y cubed, so we'll use that as our common denominator. All right, now we have our common denominator. Now we need to figure out what must we multiply 18x cubed y by in order to get 54x cubed y cubed. So we know that we have to take 18 times 3. That gives us 54. X cubed, we've already got a match there, so we don't have to worry about the x's. And here we have y, and we need to change it into y cubed, which means we would have to multiply by y squared. So now we need to also multiply the numerator by the same thing. So that's what's going to go in the numerator of this second line here. 1 times 3y squared is 3y squared. All right, now let's look at the second fraction. I have a 27, and what would you have to multiply 27 by to get 54? You would have to multiply by 2. I have an x squared, but I really want it to be an x cubed, so I would have to multiply by x. And then with the y's, we already have the y cubed, and that matches with our common denominator. So now we also need to multiply our numerator by 2x. 5 times 2x gives us 10x. Now we can combine our numerators and write our fraction as just one fraction. Combining them, 3y squared plus 10x. And in the denominator, we know we have our 54 x cubed y cubed. Now you would want to check your numerator to make sure you can't factor it. You're looking for GCFs or one of those special cases that we factored last unit. And in this case, there's nothing that we can do to factor, so we are done. All right, number 6, we need to add these two fractions, so we need to get a common denominator. And both denominators are trinomial, so we know we're going to have to factor those. So on the first one, we're looking for factors of -10 that add to -3. So I'm going to list my -10 over here, and let's write our factors out. 1 and 10, 2 and 5. And in order to get a -3, I'm going to have to do a +2 and a -5. So I'm going to write that here, x plus 2, x minus 5. All right, now the second one, we need factors of 2 that add to 3, well, there's only one factor of 2, 1 and 2, and that adds to 3. So we can go ahead and factor that. X plus 1, x plus 2. All right, so now we have to gather up all of our different factors, and that becomes our common denominator. So it looks like our common denominator is going to be x plus 2. Both of them have an x plus 2. X minus 5. And then we also have an x plus 1. Now when we look at the first fraction, we have x plus 2 and x minus 5, but we don't have the x plus 1, so that's actually what we need to multiply by in order to make this into a common denominator. So the first fraction needs to be multiplied by x plus 1. So when we actually multiply that out, that gives us 3x squared. I'm just distributing the 3x plus 3x. All right, the second fraction, we have x plus 1 and x plus 2, but we're missing the x minus 5, and it looks like I wrote that wrong on the second one. Let's fix that quick. So we're going to need to multiply our numerator by x minus 5 in order to change this fraction into having the common denominator. All right, so when we multiply that out, we have 2x times x, which is 2x squared. And we have 2x times negative 5, which is negative 10x. Okay, now that we have a common denominator, we can combine our numerators and write it over that common denominator that we have. X plus 2, x minus 5, x plus 1. So let's look at our numerators. I have a 3x squared and I have a 2x squared. That would add to 5x squared. And then I have a positive 3x and a negative 10x, which gives us negative 7x. Okay, check the numerator out. Can we factor it? Well, the only thing that we could do to factor that numerator is take out a GCF of x. So if I take out an x, that leaves me with 5x minus 7, which is not helping us cancel anything in the denominator, but that's okay. We still factored it. And that's it. There's nothing that we can cancel, so we're done. All right, question 7. We're subtracting. Now, the best way to do subtraction, in my opinion, is change this to a plus sign and change all of the signs in the numerator after that. So I'm going to change that to a negative 2. Now, we don't have to do any factoring in our denominators because we just have a binomial in each. So we're just going to gather those two terms up and we're going to call that our common denominator. So our common denominator is going to be x plus 5, x minus 3. So if you look at the first fraction, you can see that it's missing the x minus 3. So we need to multiply the numerator by x minus 3. So we have x times x, which is x squared. We have x times negative 3, which is negative 3x. Our second fraction, we're missing the x plus 5. And so we have negative 2 times x, which is negative 2x. Negative 2 times 5, which is negative 10. All right, now we're going to combine like terms in the numerators. I only have an x squared, so there's nothing to combine that with. I have a negative 3x and a negative 2x, which is a negative 5x. And then I bring down my negative 10, and I copy down my common denominator. Now I can look at my numerator and see if I can factor it, because sometimes you can. This one, we would be looking for the factors of negative 10 that add to negative 5. There actually isn't anything that multiplies to negative 10 and adds to negative 5. So we're done. That's it.